So for a summer electronics project, what I set out to do was build a stereo amplifier based on vacuum tube technology. I questioned several things. Did I want it to be entirely vacuum tubes, or did I want some solid state components in there, specifically relating to the power supply, or when it came to regulating current in different parts of the amplifier. But in the end I decided that where possible, and in the final case it was completely vacuum tube technology. So I set out. I needed to learn quite a few things. I didn't know much about configurations of amplifiers in general, since I was taking Electronics 2 at the same time. So I needed to learn the difference between different configurations. I read about single-ended output stages, push-pull output stages, different configurations for the amplification, self-inverting push-pull configurations that didn't require phase splitters, quite a number of different kinds of configurations. But in the end I decided on the circuit that you're seeing here, which is just simply a pretty classic configuration, a preamplifier stage accomplished by a triode, 12AX7, or actually in this case it's a ECC 83 or 803S is the tube I actually used, followed by a phase splitting stage. I still get some amplification here, but the main purpose of the stage is to separate the phase of the signal by 180 degrees so that it can then run into the output stage, which in this case is a push-pull configuration. I use a output transformer that is a 8,000 to 8 ohm impedance transformer, with a design to provide 15 watts of output per channel. My power supply, even though this schematic that I'm basing it off of says that it's using a 400/400 power transformer, you didn't really need anywhere near that power to power the circuit. And in fact you end up wasting quite a bit of power in this resistor. I used a 550 volt power transformer, center tapped, so I get plus and minus 275 volts. But it was quite a fun process. I had to learn quite a bit about the tubes themselves. My rectification is handled by this GZ34 tube. The GZ34 tube, as you can see in this data sheet, it's quite simple. 2 diodes, so I take my plus and minus voltage from my power transformer and rectify it into DC. The power supply then does quite a bit of smoothing, and through different steps I get the different voltages I need at different points in the amplifier. I run approximately actually 310 volts to the EL84 tubes. The EL84 tubes, although rated for 300 volts, I found different data sheets that run them as high as 315 volts to achieve as much as 17 watts output at the output stage. But I had to learn quite a bit about these. The 15 to 17 watts is about the limit that you can push an EL84 tube, and I am trying to push the limit of those tubes in this configuration. And then the phase splitter stage, I'm using the same tubes as my preamplifier stage, which is in this schematic it's being labeled as an ECC 83. Which is the same as a 12AX7. The tubes I ended up using were JJ Electronics ECC 803S's, which this is the data sheet for. These tubes are dual triode tubes, and they have a GM of approximately 100. So I can get quite a bit of gain. In this configuration, I'm getting about a gain of 25 in the phase splitter stage, and in the preamplifier stage I'm getting a gain of about 65. All told, I get a gain of between 15 and 1600 in the circuit. So this was the design I used. The schematic here is what I based it off of. I didn't make very many stages. I did, however, split the current right at the output of the rectifier tube to lower the wattage I had to put across the resistor prior to my first capacitor, just because it was quite a bit, and resistors that can handle wattages this high are pretty hard to find when you didn't know exactly what you needed before prototyping the power supply. So I split the power supply right at the output of the rectifier tube, used an additional 40 microfarad capacitor, and then I just wanted to step through some of the construction photos before showing you a video of the resulting amplifier. As you can see, I'm using a cake pan as my aluminum chassis, and this is me laying out the components, drilling the holes in the chassis, mocking it up. In this photo you can see the tubes, the output transformers, the power transformer, and some of the components on the back. Right now you can see my speaker terminals are mounted directly to the aluminum, which obviously short circuits the output, so later on I had to, as you can see here, replace that with a piece of wood so that didn't short those connections. These are some photos of the etching process where I was laying out some of the boards for the interior of the appliance. The etching worked out really great, actually, and when all was said and done, it saves a lot of space on the inside. This is wiring the internal of the amplifier, the voltage from the wall. I run from the plug. It goes across a fuse holder before going across the main power switch, and I've got the earth connection from the wall connected to the ground in the system, and everything's grounded to that point. This is all the spaghetti wires. When I'm wiring the leads to the tube sockets, I've got about a foot extra wire on each connection, so it's not as messy as it appears. Once I mount the board, as you can see, and start making the connections there, things start to get cleaned up quite a bit. So this is part of the testing process. I tested all the stages outside of the chassis prior to trying to incorporate them inside, and this was some of the last work I was doing in the power supply to make sure I had that tuned to provide the right voltages at the right points in the circuit. And as I'll explain later in the video, I've run into quite a problem that I can't identify. At first I thought it was resulting from something possibly in the etching of the board, but after testing that outside the board, I think I've located the problem to be either in the preamplifier tube socket or in that tube itself. So I'm not quite sure, but I attempted to simulate the circuitry of the cathode for the preamplifier stage outside the board and see if I could resolve the problem, but I can't, so I do think it has to be something in the tube or the tube socket itself. But we'll look at the rest of the video for more. Well, here we are. It's the end of the summer, and this is my amplifier that I've been building for electronic projects. I think it looks beautiful. The design is for a 15 watts output per channel. Uses 8 tubes, a rectifier, which we do all of the AC rectification by tubes also. a preamp voltage amplification tube, 2 triodes working as phase splitters, 1 per channel. Each of these triodes is actually 2 triodes per tube, and then 2 EL84 push-pull power output tubes. We're using a power transformer that steps the voltage up to 550 volts center tapped, so I get plus and minus 275 volts. And the output transformers are designed for 15 watts of output. Let me move this so you can see what's going on in the back. The wood panel's attached because I needed something non-conductive in order to make sure that these terminals didn't ground out with each other. I've got RCA jack inputs here and the speaker terminals for the output there. There's my wall voltage in. I've got a fused power supply, and then of course the main switch. So the main question is, hey Mike, why are there still wires sticking out of your wonderful amplifier? And that comes down to the problem that I'm having with the design. And I'll stop the video and come back when I open it up so we can take a look at what that is. Okay, so here we are, and if you'll notice, the amplifier is upside down, but everything's still plugged in. But we've got the chassis opened up so that we can take a look inside. As you can see, there's a lot going on in here. I was actually really happy with, I'm really happy with just about everything. The circuit boards I etched myself and laid out and assembled them, and they seem to work just fine, although I questioned one of them for quite some time. But nevertheless, let's take a look and see what's going on here. If you'll notice right off the bat, the large open space here where there is nothing is where the yet to be assembled power supply would have gone. However, once I ran into a problem with amplification in the circuit, I halted the etching of that board until I could resolve the problem, which I haven't resolved. But that should be etched and placed essentially right around here in the chassis. The power supply is working fine to design. We're getting roughly 340-ish volts RMS rectified out of right out of the rectifier, which comes into the power supply. It goes across a series of resistances and capacitors to deliver different voltages to different stages of the power supply. I'm getting about 305 volts out of the top of the power supply at this point, which is delivered to the output stage. That steps down then to about 245 to 250 volts at this stage. That goes to the top of the phase splitters, and then about 210 to 215 volts that goes to the top of the preamplifier stage. As I said, that's working fine. And one of the things that I'm actually really happy with is that I get just about no hum out of the circuit. Now I don't know if that's actually due to good layout or good design, or if it's if the lack of hum is also caused in the problem I'm having with amplification. The power I'm having is in the preamplifier stage, which is essentially made up of this tube socket here. There's 2 triodes in there, and they serve as the triode for both left and right channels. And then on this board, the circuitry that I'm pointing at is the assembled components that run into the cathode of the preamplifier stage. Now these should be biasing the preamplifier stage to have about 500 millivolts at the cathode on the preamplifier, but they're not giving me that. I'm not sure what the problem is. I tried to investigate if it was a problem with something shorting out on the board, maybe due to the etching process, something like that, or if components were bad. I've been scratching my head over the issue. I tried to actually recreate the same circuitry on a breadboard and simulate just that portion of the amplifier off of the etched board, but it didn't seem to solve the problem. As it is right now, my suspicion is that the problem actually lies in either the socket or the tube itself. I question whether or not it would be the socket. Other parts of the socket seem to be working fine. I'm delivering the right voltage to activate the heaters, but the tube itself isn't getting very warm. So I'm wondering if the problem is actually in the tube. However, at this late stage, I don't have time to reorder the tube. I'm going to reorder a tube. I've put a little too much money in this project to just let it go. And besides, I'm really excited to have this amplifier working. But nevertheless, I'm not getting amplification at any later part of the stage because I'm not amplifying on the preamplifier. I did do as suggested and actually simulate the stages individually, and they worked fine. I got the gains I was looking for, which was approximately a gain of 65 on the preamplifier stage, a gain of about 25 in the phase splitter, and then gain slightly more than 1 or 2 in the output stage. I can't remember directly, but I do remember, though, that my overall total gain was between 15 and 1600, depending on bias points at different mock-ups. So the design is working. I just obviously have some problems to work out. Those are my 8-ohm non-inductive 20-watt resistors that are simulating speakers at this point. But I really hate that I've run out of time in the summer, but I have to turn something in and show the work I've done. It's been quite a bit of work. I do hope that even without a working amplifier, that the project can be considered to be a significant enough work for a good grade in the class. Another smaller project I wanted to show, something I worked on at the beginning of the summer. This is a headphone amplifier I worked on. It uses a 12AU7 tube to handle voltage amplification, and then per channel a MOSFET and a common collector configuration to amplify current but not voltage, and then LM37 to work as a current regulator to bias the circuit. It doesn't give a whole lot of gain, but then again it's not designed to. It's essentially set up to run from the output of my laptop, which is already doing quite a bit of amplification itself. But it was a project that let me learn quite a bit. I used it as a way to familiarize myself somewhat with the theory of amplification in the tubes, but also that of MOSFETs, and also to learn the skills of etching boards and laying out the circuitry, that kind of thing. So just want to show it off. This works fine, but it's not the amplifier that I really set out to do as my summer project. But all in all, it's been quite a great experience, and I really do hope to have it working within the next little bit. I got a new set of speakers that I hope to pair this with. Anyway, thank you for looking at the work, and hope to talk to you soon.